Test. Let's wait for the guys to come in. Okay, let's see if it's it's working. So the idea here would basically create a simple calculator being as verbose as possible using Java. I don't know if I should stream this in English or Portuguese, because most of the people, I guess, would be Portuguese speakers. So if there's too much Brazilian Portuguese speakers, I guess I switch to Portuguese, and yeah, that's it. So yeah, let's start it. Yeah. So first of all, we need our interfaces, right? So yeah, interface a calculator, and then it will have public void. It will have the four main operations. Let's say public int add numbers, and then it takes an int. Yeah, let's leave it like that. And then the public int subtract a numbers. Let's say public int divide numbers, and we're not even close to the crazy stuff yet. So public int multiply numbers. I think that's okay. Yeah. So I guess it would be interesting to have some sort of factory for the calculator, like a calculator factory or something of sorts. Let me check how things going up there. So being verbose as possible in Java is kind of dangerous. Yeah, for sure. Yeah, Antonio, you're absolutely right. Yeah. So okay. So right. So let's create an abstract. Let's create. Let's name this abstract calculator. Right. Abstract calculator interface. Now let's create an interface for a calculator factory, an abstract calculator factory interface. Okay, this is not even close to insanity yet. We'll wait for it. We will get there. So yeah, we need. No, we need something like a public void build calculator. Okay, so it will output a abstract calculator. Okay. Oops. It would take an argument. Yeah. So, oops. No, I think that's correct. So it's a factory, it's an abstract factory for building calculators. Yeah, I guess the class should be a singleton because yeah, it doesn't make much sense to instantiate a factory. In this case, I'm not really sure. Let me check. Let me. Well, never mind. I can check this later. Okay. So yeah, things are getting quite messy already. So yeah, we have an interface, an abstract calculator interface, an abstract calculator factory interface which builds calculators. Okay, so yeah, let's create a class, concrete calculator, which implements abstract calculator interface. Okay. And what's the matter here? The type I must implement then inherit as okay. So yeah, we have our public int add numbers when we have int a and int b, two numbers, and this method must return a result of type int. Okay. So it's getting a little bit ahead. So let's return a plus b. I think we could complicate this method a little bit, but yeah, we'll see about that. Because you could have an abstract interface for adding numbers, like an abstraction for adding numbers, because you could have any sort of add on an abstract addition, then add two numbers could be an implementation of this. Well, we'll see about that. We could get really crazy here. So yeah, let's go with a public int subtract numbers, and then we have int a and int b, and then return a minus b, I guess, or b minus a. I guess it should be a minus b, right? And yeah, so public int divide numbers. Yeah, if anyone has any suggestions of how this could go on very crazy, please let me know. I'm really trying to break things here and be as verbose as possible, and yeah, really go all in the Java programming style. So here dividing is tricky, because you can't divide by 0. So yeah, let's try the following. If b is less than less or equal, if b is equal to 0, and then yeah, we throw an exception. Syntax error. Okay, throw exception. I think we should have exception cannot be resolved as e. Yeah, no, that's not correct. If b is equal to 0, let's make it simple. Let's just system out print line error division by 0. And then we return yeah, we just return 0. Okay, so yeah, that doesn't make too much sense, but yeah, let's go with that for now, because I forgot how to throw exceptions in Java. I'm not really a Java programmer, so just messing around a little bit. And finally, we have public int multiply numbers, int a, int b, and yeah, a times b. Okay. Let's implement the inherit. I guess here it should have the arguments. Here are subtract, divide numbers, multiply. Yeah, I think I missed here the, yeah, now it's properly working. Let me try to remember how to throw exceptions in Java, because I really forgot about that. I want to throw throw new exception. Okay, let's do it like this. Throw new exception, and then error division by 0. Okay, and then so why is he complaining here? Unhandle exception, type exception. What's going on here? Throw new, handle. Throw new exception, and then string message. Yeah. So yeah, I got, and I will not ask ChatGPT to help me on this one here, because you know that's let's try the following. Try and then catch division. Oh, now I'm screwed. ChatGPT is off. Oh, damn it. Now I'm completely screwed. Throw new. Handle exception, type exception. Let me check. It has to be inside the try catch block. I don't remember. Okay, let's do the following. Try, and then no. Python, this is so much easy. Yeah, this is starting to get on my nerves already. If else, okay, here I tried this in Stack Overflow, and apparently this should work. Throw a new exception and then the string. Unhandle exception type. Oh yeah, it's because I guess it's because we are not handling the exception, and yeah, we're not doing anything with it and just letting the program crash. That's why it is complaining about it. Yeah, so you don't have any try catch here, and then it would just throw this exception, then let the program crash, and yeah, that's it. Yeah, never mind. Yeah, we're and then later we'll see about that. So let's recap. So I don't want this. We have this abstract calculator, abstract factory, abstract calculator factory, and then we implement our we have our concrete calculator, which implements the abstract calculator interface, and then we have all these methods here. And yeah, now we can, I guess, implement our a calculator factory, right? So class concrete calculator factory implements abstract calculator factory interface. Yeah, probably at some point I'm gonna run out of space here because I have to let years be I have to use a large font size, or otherwise you won't we'll be able to see anything. So yeah, so it should be a static class here, and then yeah, so we have concrete. Actually, we don't need yeah, we need this public abstract calculator, and we need this method here, which then we'll implement. What did you complain about? Illegal modifier for the class, only public abstract and final are permitted. Okay, so no singleton here. So okay, and then we return should create an instance of the calculator. Concrete calculator, concrete calculator, concrete calculator equals new concrete calculator. Okay. So yeah, then we return the concrete calculator, yes. Yeah, it seems to be properly working. So yeah, this is what they will call, I guess, dependency in the injection, like when you insert an instantiation of a class inside another class, and they return it to another class. I guess here we could use the constructor for this class instead of using a function like this, but I would just leave it like this, using the function build calculator, because my main idea was to use this as a singleton. So then we will have to move to another file, and then we have to create a package and so on. And I guess that, yeah, that will get messy. So let's check Twitter for a second if something's commenting something right here. Okay. So yeah, back to YouTube. So we got yeah. So I think this is pretty much simple, yet to some extent. So yeah, we could get a little more crazy here. So yeah, let's do that. Because the title of the video says coding in Java until I go insane. So let's go insane. Interface abstract summation, and then we have add public we should call it we could have an abstract number as well. So yeah, we have interface abstract number interface, right? Okay, abstract number interface. Okay, so yeah, I guess it shouldn't have any method here, and just be like, you know, the interface for the sake of interface, because we want to use it here. So we return an abstract number, public abstract number, abstract add. Just call it add, okay. And then we have this abstract number interface. So we can have an abstract interface for each you know, each mathematical operation, right? So yeah, interface abstract subtraction interface, and then we use the abstract number interface subtract. We have to implement all this stuff, right? At some point. Interface abstract. Yeah, this will be multiplication interface, and then public abstract number multiply. It would take actually we have to pass the arguments here, so it will be abstract number interface A and abstract number interface B. Also here A and B. You know, I already run out of space here, so yeah, it's great. Here A and B. I gotta waste some water, so yeah. And yeah, an interface for a abstract multiplication. So abstract, sorry, not multiplication, division, abstract division interface. Yeah, so public abstract number interface divide abstract number blah 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 a abstract blah 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 oops. B. Okay, so now we have our interface. We have I guess we could abstract, we have abstract everything that we could possibly think of. If you guys have any idea of what we could possibly abstract further, I'm open to suggestion here. So yeah, let's make it verbose and as complicated as possible. That's the idea, yeah. So yeah, now we have to implement all this. So let's create a class which implements the abstract number, and it will be an integer, right? Because yeah, you know, we could substitute this for the class afterwards, because why not? Okay, so let's leave our interface up here, and then our classes from where is it? Okay, so this will be all the interface, and then the class we leave. Let's use this as a divider. And I almost forgot to save this, so I would lose all progress. So yeah, let's implement. Oops, where was I? Oh, okay, so this goes up here. Okay, from here, from the bottom, from up down, here is classes, and then here is the interface. Okay, so we have a class concrete integer number which implements the abstract number interface, and then yeah, and then we use the constructor, and it's simply it would take let me think, int n, okay, and let me check something. regarding construction, so I don't mess this up. So we have to assign yeah, at some point we're gonna have to use the built-in a built-in, oops, I opened the wrong window here, a built-in data type such as int. So yeah, we won't be able to get away from that. So yeah, so it would be private int n. Okay, so, and then in our constructor we could use getters and setters here, I guess, or we could simply set it as, I don't know, this dot n equals n. Okay, but then yeah, let me think a little. Getters and setters. Yeah, we should keep this private because it's said that this is the best practice in object-oriented programming. You know, we're messing this thing up, and yeah, we're making fun of it, but we should stick to the best practice. So let's say we have a concrete number, then let's make the getters and setters. Okay, so public void set integer, and then we take int n, and yeah, this dot n equals n. And what's this company? The value of the field concrete is not used. What do you mean it's not used? In the value. Yeah, this is weird. Okay, so let's write a getter, public int get integer int n, and we don't pass any arguments, and then we return this dot n. Okay, so we got ourselves the getters and setters. Okay. So the next step would be, yeah, so we have to replace this int here by our concrete number, and our concrete calculator takes also an abstract number here and here and here. It's all abstract numbers, and then we substitute them for their implementation. So yeah, here we have a concrete number, and then return also here. Operator is undefined for the argument. Okay, in Java we don't have operator overloading. Yeah, that's the problem. And if it was C++, we could implement our operators. So here we have to use the getters. Also Python, we could use operator overloading here, but you know, this is Java, right? We can only use operator overloading with their built-in functions, right? So yeah, that's a bummer. That's, you could say that the verbosity is the thing that I most dislike about Java, but in reality it is the the thing that you don't have operator overloading. Yeah. So here we have to do something like this. Integer concrete integer number and was new concrete integer number. So yeah, here we simply pass this here. Yeah, this is getting very crazy. And then we return and here, and yeah, so now it's coherent. Now also we have to do the same thing. Here it will be, actually here will be all return, and let's just copy and paste. Here it will be a little more tricky, but we take this one for, we handle this one for last. So here we use the getters and setters to get the int so we can instantiate a concrete integer number and then return it. Yeah. And let's see how many or what. Okay. And here, yeah, let's copy paste this. Yeah. Okay, and then we have division. Okay, so let's create a, if a dot get integer is equal to 0, we throw an exception, right? And then else we, yeah, and then we simply return n. What's the problem here? Unhandle exception. Okay. What's the point company? This method must return the result. Oh, okay, we forgot to. And then here, I think we're almost done with our crazy calculate. What is the problem? The type must implement the inherited abstract method. So abstract calculator, where is it? Concrete integer number implements abstract number. Did I forgot something? A abstract number interface, a b. Yeah, this is starting to get a little bit offhand. So abstract number interface. Abstract division. Actually, we didn't use the abstract division right here, so we simply use add numbers. Yeah, that's the problem. Must implement the inherited abstract method. So it takes subtract. let's check the interface. Abstract number interface. So here, concrete integer number implements abstract number interface, and then here it returns, yeah. I think we should implement these abstract interfaces here, so perhaps we could get yeah, we could lose ourselves completely over here. So yeah. So let's try class concrete summation implements abstract summation interface, and then it has a method concrete integer summation, and then it returns a concrete integer number for add, and it takes a integer number A and integer number B, concrete integer number doesn't even inherit abstract methods, and then we return A plus get integer. Actually, we did the same thing as here. Return n. Well, but we are implementing the abstract method, abstract number interface. Let's try it with abstract summation. Dot add abstract number interface and abstract number interface. Type concrete integer summation. No. Yeah, what's going on here? What is he complaining about? It should have the same type. Here instead of concrete, it should have concrete integer summation. Where is it? So here is it. Let's check it. Oh yeah, I think we should use this over right here. A super type method. No. So keep your existing method, create an empty display method, correct the current method to the interface version. So abstract summation interface, where is it? So no, that's not correct. I guess we're missing something. Abstract number interface. Where is it? Implement. Yeah, I guess we should use in our abstract, where is it? Abstract summation interface, we could use a concrete integer number. Where is it? And then reduce the visibility of inherit method. Every time I got a different error here. So yeah. I guess this should be a constructor, perhaps. Yeah, let me try something. So I got concrete abstract summation. Okay, so I had to rely on ChatGPT and I pasted the following. So what is wrong with the following code? So I pasted the interface and then the class implements the interface, which is giving an error. So it says the code is trying to implement the add function method in the concrete integer summation class, but is not overriding the add method from the abstract summation interface. The implementation of the method in the concrete integer summation class should have the same signature as the method in the interface implementing, which means it should take in the same types of arguments and return the same type. Additionally, the method should be notated with override. Okay, so here we got our interface. Here we got our interface, and then so this is pretty much the same. And then we have our class, which implements the interface, and then we use this override decorator. And abstract number interface is the same, abstract number. And then okay, so I think I got this. So integer abstract number, and here we use overrides. Cannot reduce the visibility of the inherited method. Okay, so I was missing public. Get integer is undefined for the abstract number. Could use find the get integer method in the abstract number interface or in some class that provides. Okay, so let's create a get numbers. So it is more general. I could use find and replace here, but so get number, set number, and no. Override here and here. Where is it? Abstract number. So void set number. And then Yeah. So we got some things to work on here. Set number. We could, let me think. Yeah, this is getting a little bit too much, I guess, for in terms of abstractions, so we're trying to go extreme here. And yeah, the abstractions are breaking, so let me check. Their message telling you that get integer method is not defined abstractly. The card can provide the add method. It's trying to call the get integer method in the AB argument of type abstract number. However, because the integer method is not defined in the interface, the code not work. This is expected since in the interface you only define method signature, but not the implementation details. Okay. In order to fix this issue, you need to define the get integer method in abstract number interface class, or in some class that implements the abstract number interface. Or you have to find another way to extract it. Okay, so I guess let's just leave this out of here. And then what is complaint here? Is undefined for abstract number interface. Yeah. The problem is that we have to we use this type here. Let's call this concrete integer calculate. So ChatGPT says that the abstract number interface should have an int get integer. Yeah, I guess we can't escape from it. So yeah, this was not what I had in mind, but yeah, we can have it like this then. Get integer and then integer like so. Get integer. And then the other method, set integer. Okay. So now, what's complaint? The method get number is undefined for concrete. Get number is undefined for concrete integer number. How is it undefined? Ah, yeah. Override. So yeah, we have concrete integer summation. And okay, now we are on the concrete integer calculator. And I guess we have to correct some things. Abstract number interface. Actually here we want to implement abstract summation, abstract multiplication, abstract division. Yeah, let's swap this off order because that seems weird. And swap division. Yeah. Then we got abstract number. Let me check something. Abstract. Okay, so it is abstract number interface, and here, yeah. Okay, so it's coherent. Abstract calculator. So we implement a concrete integer calculator, which, yeah. So public concrete integer number. So where is it? Our concrete, we have implemented concrete integer summation. Yeah, now we have to do for the other ones, like concrete integer subtraction, abstract subtraction interface, and then subtract. Probably we'll have to make some changes here on these interfaces. So yeah, so concrete integer summation, concrete integer subtraction, and now concrete yeah, concrete multiplication. Oops. Concrete integer multiplication implements abstract multiplication. Yeah, so here it's multiply, and we override, and here it's times. Yeah, and the last one is division. Okay, here's division, abstract division. What's wrong here? Okay, so it's divide, and yeah, we will have to throw an error for b, but I guess if b is equal to 0, but yeah, let's do this try. And oops, catch exception. What is the syntax? Okay. Catch exception E. So if they try to, if the what is going on here? Syntax error. Oh yeah. So we throw new exception, and then oops, unhandle exception type exception. Yeah, I don't know what's wrong with that. So let's try this. If b.getInteger is equal to 0. We throw a new exception, else, and we can remove this. Oh yeah. So now we have our concrete okay, now we have our concrete integer operations which implement the abstracts in mathematical operations, the summation, subtraction, multiplication, division. And then we have to implement our concrete integer calculator, which we use it will use the this implementation here. So let's check if the abstract calculator. So abstract summation. Okay, so these are the methods we need to override. Okay, so let's copy this, and then we need to override. So concrete subtraction, concrete, and yeah. So here's our, and then we do we leave our concrete calculator factory for last. Okay, so let's override and override and override. Yeah, and now we can call an instance of the classes implementations, and let's create it. Let me think. Add numbers, abstract number interface. Okay. I guess here we will need a constructor. Yeah, because we will need to store this here. Yeah. Probably we'll need a constructor here. Unless, yeah. So let's try with summation first. So private abstract number and then we use yeah, the constructor. I guess we will have to copy this for the other classes as well. And then this point b equals b, and this is not used. Okay. Let's call this X and Y just to not I'm thinking if it is really necessary, this constructor here. So let me get back to add numbers, and then we call, yeah, because we have to instantiate. No, actually don't need this here because abstract number, concrete number implements. Yeah, we don't need this actually. So what we do need is, let me think a little bit. So yeah, we have to instantiate this somewhere, probably on our main function here, and then we simply call, we create a new what was the name again of the class? A concrete integer summation. Integer summation. Integer summation, and yeah, it should be a singleton, right? If I'm not mistaken, yeah. Integer summation dot add A and B, right? Public abstract summation interface. Whoops. But we need to return these results over here, so let's go complete integer summation. It will return n. Okay, so it returns a concrete integer number, abstract number. Concrete integer number is an implementation of abstract numbers, so yeah, it makes concrete abstract summation interface. So we return, yeah, we return an instance, but at some point we have to return the result. So we should have a getter for this. Okay, we perform the add, and then we return the result. Yeah. Abstract summation. Let me check abstract calculator. Abstract summation. Okay, so this is the abstract summation. We could do some sort of I guess dependency injection here, and then here simply return the number. Yeah, I'm thinking something like this, abstract number interface. So let's change it this here, and then return. So yeah, that makes more sense, I guess. So we have to modify this interface here. Yeah, I'm starting to get a little bit lost, but yeah, I guess it will work just fine. So we do this dependency injection here. Where is it? Yeah. So here we got a dependency injection. Yeah, it's just starting to sound very weird, and I'm starting to lose my mind. Which time is it? It's yeah, it's almost 11 p.m. and I'm probably dehydrated at this point. Yeah. So I guess things are starting to make sense. We try to complicate this as much as possible with interfaces and abstractions and dependency injections for just summing up numbers and dividing, multiplying numbers. So yeah, we made something completely insane. Yeah. So yeah, the goal is code in Java until I go insane, and I'm not going insane yet, but I'm starting to get a little bit lost on what I'm doing. So yeah, okay. So back to it. Concrete integer subtraction. Integer subtraction equals new concrete integer subtraction. Here's our dependent. Our dependency injection, and then we return integer subtraction dot subtract. Okay, so this will return an abstract number interface. Okay. Okay, now for multiplication, so concrete integer multiplication. How much time I'm doing this? Just for keeping track of time. Yeah, 1 hour and almost 50 minutes. Yeah, crazy stuff. Crazy, right? So integer multiplication. Let's get the spelling right. And here is what is it? Concrete integer. I copy and paste this. What I'm doing, and then we return integer multiplication dot multiply a and b. I guess here we could use a constructor, which makes more sense than writing a method for it. If you think in terms of objects, yeah, this sounds a little weird. Like we could simply return, instantiate it with a and b, but I guess at this point we'll leave it like this. But yeah, it sounds a little bit weird, right? So let's write just this one right here. So concrete integer division equals concrete integer division. Yeah. So return an integer division dot divide. And yeah, we're almost there, I guess. So let me check. Yeah, this is ChatGPT. Yeah. Let me check Twitter real quick, and okay. Yeah, people are saying to people are saying me to say to me to stream on Twitch. Yeah, that's. But I don't have any sort of a video on Twitch. The idea is to promote the YouTube channel. So yeah. Yeah, whatever. So if you're watching right now, you can say hello in the chat and ask something to me, or yeah. So let's finalize this. What is concrete calculator fact? The concrete calculator will resolve to. Oh, okay, so it's concrete integer calculator. Okay, so we got our calculator, we got our abstractions, we got our factory, and I guess we are good to go. We can test this in the main function. And there's still one thing it's complaining. Oh yeah, there's this handle exception. Yeah, we can test it. So first things first. First, we need an instance of the calculator of the concrete calculator factory. Okay, so concrete calculator factory. Let's just call it factory equals new concrete calculator factory, and then yeah, it will return an instance of a calculator. So yeah, a concrete integer calculator will be equal to factory dot build calculator type mismatch. Can I convert abstract calculator into a concrete? Okay. Right. So I guess we could use abstractions here. Like, if I'm not mistaken, this is the Liskov substitution principle, but I might be mistaken since I'm not that much familiarized with solid. But let's see. Why are you engaged on practicing Java? Nice job, man. I'm going to follow your lives from now on. Yo, well, thanks, man. Why I'm engaged? Well, because you could say I'm a masochist. Like, I like to suffer, and life is just suffering, and I like to. Yeah. No, seriously. I guess it would be to practice, because I like to practice and learning language. And yeah, I work mostly with Python, C, C++, but in Java, and also we've started working more on Golang. And Java is a language that I haven't worked that much. Also some PHP and Node, but yeah, I would say the language that I have worked the most are by far Python and C and C++. So yeah, Java is a language that I haven't worked that much really. So yeah, we got our calculator. Now we can start. Yeah, where is our calculator? So here's our concrete calculator, and we can start adding numbers. Abstract number interface. Yeah. Okay, so let's calculator dot add numbers, and we have to declare some numbers here. So abstract number interface A equals new concrete integer number, and let's play with 1 and 2, I guess. Abstract number concrete integer. Okay, one. Yeah. One and no, let's move it to 3 and 2. Okay. So add numbers A and B. Dot get integer. So int get integer. Shouldn't it be void a getter or concrete? Get return. No, it should be get. Yeah. I'm getting crazy here. So yeah, this will return an int, and then we can start printing. Okay. So let's print there's result system.out. I will not write abstraction for that. Sorry, system.out.print a plus b, and this will stay out of the abstraction. Sorry. But we could write one. Yeah, we could write a class for that and an interface and so on. Yeah, we could get a little more crazy, but for now, let's just. I want to see if this whole mess actually works, right? Because we messed around really a lot here. It's not print line a minus b. So yeah. It would be calculator dot subtract numbers a and b dot get integer. So let's try with remaining ones, multiplication and division. So multiply numbers and divide numbers. Okay. It's time for the truth. Okay, so first javac, javac, I don't know, main.java, and reporter exception must be caught or declared to be thrown. So regarding this, let's simply return 0 and then simply output, because really I don't remember how to handle exceptions in Java. Type mismatch, return. We return. We could exit program system dot exit. So exit status 1. Okay. So let's try again. Missing return statement where 9.3 system.exit. Missing return. Null type. yeah, I don't know what I'm doing here. So yeah, we simply return a, right? I don't know why he's complaining about that. So we got a warning. What? Yeah, what the hell? I'll take a look on the. Oh my god! Look at this. Just look at this. How many interfaces here? This is a nightmare. Really, this is an absolute nightmare. I'm gonna have nightmares with this. So let's see if this works. Java main. Okay, and yeah, apparently it worked. So let's check. So yeah, 3 plus 2 it's 5, so 3 minus 2 is 1, 3 times 2 is 6, and 3 divided by 2 it's integer division, so it will round up to 1. So yeah, let's to make it avoid it rounding up, yeah, just let's make it, yeah, so we got 2 here. So apparently it works despite me trying my attempts at making it almost impossible to comprehend and complicate as much as possible. Despite all of that, it worked. So yeah, I guess I didn't try hard enough using these abstractions to make me mess up everything. But yeah, we end up not handling properly the division by 0. So let's see what happens if it makes division by 0. Yeah, it prints division by 0, and then yeah, it doesn't show up anything. So yeah, I guess it's working properly, but I wanted to throw an exception. So yeah, I'll take a look on that on another moment. So yeah, I guess I survived coding in Java and didn't go insane this time. But to be fair, it was a pretty simple program if you think about it, like you know, a calculator. So yeah, you can complicate it, you making interfaces for everything and abstractions, but in the end it's simply a calculator of ints, and yeah, so yeah, despite my best attempts, this worked properly. I don't know if everyone would be interested in this source code, like uploading it to GitHub. It sounds really silly to me, but yeah, why not? And yeah, so I guess this is it. I don't know if you guys have any questions. Vocês podem perguntar em português também, que eu acho que só tem gente que fala português aqui, então é isso aí, gente. You can ask in English, also in Portuguese, yeah, whatever. So yeah, because I'm editing this video right now, and it worked, and this is it. So if you guys don't have any questions, I'll end in this streaming right now, and I guess go to sleep and yeah, try to get my sanity back, right? So yeah, let's see if there's anything in Twitter. Yeah, people are asking me about COBOL. Yeah, I'm not coding COBOL. Yeah, this is not going to happen. Sorry guys, COBOL is too much for me. Yeah, Java is like the most insane I will get in this channel. Like, but COBOL, yeah, I could do some Fortran though. I when I was in undergraduate school, I did some scientific research, and we made some physical simulations of computational fluid dynamics, and our source code was in Fortran. Of course, it wasn't the old version of Fortran. It was Fortran 1995, which is a more modern. I believe Fortran these days it supports classes and object-oriented programming. So yeah, it's not that bad. So it's pretty similar to C. Actually, you have to do memory allocation, but yeah, it's pretty modern Fortran these days. So. Yeah, no, COBOL is very different than C. C is much more efficient, and its syntax. If you think about it, C syntax is pretty much similar to Java. Like Java borrowed a lot from C. Actually, borrowed a lot from C++, which is in turn based on C. Like you have these curly brackets. The semicolons, and yeah, it's really similar to C++ Java. It's C++ for it's C++ without having to worry about pointers and memory allocation and memory leaks, that sort of thing. So yeah, thank you guys for watching, and yeah, guys, I will be seeing you next time. For you who aren't subscribed, don't forget to subscribe to the channel, leave a like, and activate notifications, of course, and see you next time. Bye.